And welcome back. Last day of the month, 31st of May. Let's see what today has in store for us. First question. Prove that the product of two odd, so not necessarily consecutive numbers, is always odd. So I'm going to say let values be 2m plus 1 and 2m plus 1. So not consecutive, so therefore I've got m and m. And then I'm doing the product, which means I multiply them together. So 2m plus 1 times 2m plus 1 equals 4nm plus 2m plus 2m plus 1. Go back. Prove blah, 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 odd. So I need to write this in the form 2nm plus m plus n plus 1. And I'm just going to say of form 2k plus 1, therefore odd. And that will do. Bit more rigor needed at A level, but that's fine for further maths. Next question. F of x equals this, g of x equals this. Calculate the value of g of 630. That's weird, so I don't need to use the f of x at all. Okay, calculate it out, because this is definitely a calculator exam. So g of 630 equals cos of 630, which is 0. And then g of 0 is cos of 0, which is 1. And actually, thinking about it, that could be a non-calculated question, couldn't it? Because what you would do is you'd take away 360, and then you just have cos of 270, which you should know. I mean, I say that, I just use my calculator, but you should know is 0 just by the curves. Next question, and we have a simultaneous equation question. Boo. Right. And actually, I've just noticed something. That, and I presume that is intentional, is written back to front, which is not very nice at all. So let's start by just writing this out in the correct way. So 5x minus 3z equal, not x, that's a y, that's the whole point. 5y is equal to 9. So I'm going to call this equation 1, this equation 2, and the rewritten version equation 3. Now, none of the numbers look brilliant, do they? So I'm just going to do, pausing while I think about what the best thing to do is, probably y. So let's do 2 lots of 1, and let's write equation 2 underneath. So that's going to give me 10x minus 2y plus 4z is equal to minus 20. Write 2 underneath, so 3x minus 2y plus 5z is equal to 5. And then I'm going to take these away. So 10 minus 3 is 7x. Minus 2y minus 2y goes away, and 4 minus 5 is minus z. Minus 20 minus 5 is minus 25. So actually I might write that out slightly. No, let's leave it like that. That's okay. Then I need to do, well, I need to get rid of the y's again. So we'll do 5 ones, and we'll do equation 3. So 5 ones is 25x minus 5y plus 10z is equal to minus 50. And then we've got equation 3, which is minus 2x, there's not very nice numbers, plus 5y minus 3z is equal to 9. Now, I will say right now, if these numbers end up quite nice, then I'm happy I've done the right thing, but that could easily be fractions. Either way, let's add these equations together. So 25 and is 23x, not looking promising, is it? And 10 minus 3 is 7z. And 50 minus 9 is 41, so that's minus 41. So that's my equation B. So I've got equation A and equation B. I'm pausing while I think about what I can do here. I don't get much choice, do I? So let's write 7 times equation A underneath. Must be a quicker way of doing this. So it gives me 49x minus 7z, let's put a plus there, minus 7z is equal to minus 175. Now, that's a minus and that's a plus. So I'm going to add these things up. Now this is where I hope the numbers come out nicely. So 23 and 49 is 72x. The z's go away. 175 and 41 is minus 216. Oh, okay, that's okay. So therefore x is equal to minus 3. Wow. There might have been a slightly easier way or easier numbers here, but either way, that's what's fallen out. Now let's put this back into equation A. So equation A says 7 times minus 3 is minus 21. Minus z is equal to minus 25. Let's multiply everything by minus because it's just a bit easier. So 21 plus z is equal to 25, which means that z is equal to 4. Then equation 1. So equation 1, so I'm going to do 5 times x, which is minus 15, minus y that I don't know, plus 2z, which is 8, is equal to minus 10, which means that minus y, now minus 15 plus 8 is minus 7. Add 7 to both sides is minus 3, which means that y is equal to 3. That felt much harder the way that I did it, but there might be a quicker way where it falls out easy. Either way, x is minus 3, y is 3, and z is equal to 4. Question done. Final question of the month. Work out the matrix that transforms the unit square by reflection in the x-axis. So reflection in the x-axis basically means that I'm going to take my point 0, 1. If I reflect it in the x-axis, it stays exactly where it is, which is 1, 0. Then I'm going to take the point 0, 1. I think I call this 0, 1. I mean, this is point 1, 0. Then I'm going to take the point 0, 1, reflect it in the x-axis, which brings it down here, which means gives me 0, minus 1. After the last few questions, that was not too bad at all. We've finished the month, thankfully. Let me know how it went for you. June starts tomorrow, and I'll see you tomorrow. Thanks all.